Everyone. So today we are going to see the one of the question which is continuously we are getting in the technical interview, that is what is engineering tolerance, and it's explain the types of the engineering tolerance. Okay. So engineering tolerance means when we are creating the drawings or when we are creating the 3D part, right? That is the means when we are creating that things, that time we are applying the tolerance. Okay, so first we need to understand the tolerance. So what is the tolerance? The tolerance is an acceptable amount of dimensional variation that will still allow an object to function correctly. Means one of the object having some x dimension. Okay, so if that x dimension variation we are adding, okay, variation means that dimension can vary within that limit. Okay, so that variation, whatever variation, allowable variation, we are calling as a tolerance. Okay, so this is a definition you have to explain first. What is the tolerance? The tolerance is an acceptable amount of dimensional variation that will still allow an object to function correctly. Okay, then moving further, types of the engineering tolerances. Okay, so if you see in this image, okay, so you can see the dimensions are given. Some dimensions are given. Okay, so mainly there are three types of tolerances are there. Okay, so you can see the a tolerance is an acceptable amount of dimensional variation. Okay, for example, here you can see the dimension is 500 plus or minus 0 point not 005 minus not 000. Okay, so that is whatever this variation. Okay, this is actual dimension and the variation is this. So this variation we are calling as a tolerance. Here also you can see, the here also you can see, right, or here also you can see. So there are three types of tolerances, engineering tolerances. So first tolerance is limit tolerance. So what is limit tolerance? So limit tolerance you can see here. Okay, so here upper limit and lower limit is given. Okay, here no fixed dimension. No fixed dimension is not here. You can see the 500. Still here there is a no single dimension, right? Here upper limit and lower limit is given. That is we are calling it a limit tolerance. Then second is unilateral tolerance. Okay, so unilateral tolerance means this is the unilateral tolerance, like the symbolic language. When we are representing the unilateral tolerance, will represent like this. And third is bilateral tolerance. So that is this type of tolerance. Okay, so now we'll see this in detail. So first is a limit tolerance. So what is limit tolerance? So limit tolerances are two-dimensional values. Okay, stacked on top of the each other. Right, two-dimensional values. Limit tolerances are two-dimensional values stacked on top of each other. Means here you can see two-dimensional values. Here two dimension 10.7, 10.5. Right, stacked on top of each other. The dimensions show the largest and smallest values allowed. So here largest is 10.7, lowest is 10.5. Anything in between these values is acceptable. Okay, so from 10.5, 10.6, right, 10.7, anything this coming, it is acceptable. That is limit. So here limits are defined. Okay, so limit tolerances are two-dimensional values, right? Two values we are getting, upper limit and lower limit. Okay, then next is unilateral tolerances. So unilateral tolerances exist when target dimension is given along with a tolerance that allows variation to occur in only one direction. Okay, means when you are allowed the variation in one direction only. There are two directions, right? One largest, one lowest. Okay, or upper limit or lower limit. So here you can see in this image, you can see 20 plus 0.000 minus 0.004. So here in the plus there is a no value. Means here in the plus allow variation is not allowed. Variation is allowed in the minus value. Okay, minus value. So only one direction. Here variation is allowed only in the one direction, either plus or either minus. Here either plus means 20 plus 0.004, then 20 minus 000 will come. Only one directional variation is allowed. That is we are calling as unilateral tolerance. And then Third one is bilateral tolerance. So bilateral tolerance exists if the variation from target dimension is shown occurring in both the positive and negative direction. Okay, you can see here. Both the direction 20 plus 0.002, 20 minus 0.00. So both the direction variations are allowed. Okay. So within that range, we have to create this part. Okay, that is allowed. Not exactly 20 because due to manufacturing what we can say manufacturing constraint, exact dimension we cannot manufacture or exact part value we cannot manufacture, right? In design it is possible to design, but in manufacturing, due to manufacturing constraint, right, that is not possible. That's why this tolerance is important. Okay, so as an example, if you see the basic size, so basic size of the part, for example 20 mm here. Okay, so in the unilateral, if you see 20 plus 0.5 and 20 0. Okay, so only one directional value is given. So here you can see the basic size plus 0. Basic size plus 0.05 here allowed. Okay, in the unilateral one direction, right? In the second direction, same value, no variation here from the basic side. Okay, from the basic side. And in the bilateral, if you see both the variations are available, negative and positive. So 25 plus 0.5, right? Or 24.95. Okay, we have to minus the tolerance value from the actual value. So you can get, so you can see here 20 plus from the actual dimension minus also it is allowed. Okay, so these are the main three tolerances. Tolerance is allowable variation, okay, in the actual dimension. And there are three types: limit tolerance, unilateral tolerance, and bilateral tolerance. Okay, so like this you have to explain or you have to answer this technical interrogation. Lots of times you will get this question.